Example 25. A beam is subjected to a system of loads that can be represented by the load diagram shown in the figure. Determine the resultant of this system of distributed loads and locate its line of action with respect to the left support of the beam. So meaning at A, from A. Okay. So we know that our force, so you have three forces. We can locate, we can dissect or divide our system of loads into three regular shapes, right? And that is, if you try to zoom in, we have a triangle here, and then a rectangle, and then a third, a second triangle. Okay, so for our, let us call this one as 1. Okay, for this one as 2. And lastly, our force number 3. Okay, so if you can observe that the load is Newton per meter, the maximum load, right? Okay, so for our F sub 1, F solution, so our F sub 1 is equal to area 1, right? And this is equal to 1/2 base times height, and our base would be 2 meters, right? Okay, 2 meters times our height, of course, 300 Newton per meter. So our F sub 1 is equal to 2 times 300 divided by 2 is 300 Newton. And this our location of our F sub 1 from the tip, okay? From our tip is X bar X for 1 is equal to, from the tip, that's 2/3 times 2. So that's X bar X sub 1 is equal to 4/3 meter from the tip. Okay. Next, for our F sub 2, which is our rectangular load, that is base times height. Now, our base is, that is the entire 6 meters. Okay, rectangle. 6 times our height is still 300. The 300 Newton meter times 6 meters, that is equal to 1,800 Newton. Okay, so the bar X sub 2 is equal to 1/2 of 6. X bar X sub 2 is equal to 3 meters. Now, our 3 meters is not from A, but rather from here until at the center. This is our 3 meters. Okay, now for our 4/3, that is from here to here. 4/3 meter. Okay, 3 meters. Okay, now for our third shape, or our second triangle, that's F sub 3 is equal to the area of our triangle, which is 1/2. Wait, let me write this one as area 2. Okay, this is equal to area 3, and area 3 is 1/2 base times height is equal to 1/2, and our base this time is 4 meters times 4 times our height, which is 300 Newton meter again. 300. So F sub 3 is equal to 4 times 300 divided by 2. That's 600 Newton. Now, if our bar X sub 3 is equal to, so of course, if we want to measure it from the tip, which is from B, point B, the edge at point B, that's 2/3. But if we measure it from here, this is 1/3. So this is 1/3 times, this is 4. So bar x sub 3 is equal to 4/3 meter. Now, again, this 4/3 and 3m is with respect sa atong reference diri. Kani diri for our 3 meters and diri for our 4/3 for our force F sub 3 and or our second triangle. So if we want to know the resultant force, so we simply F sub R is equal to the sum of all forces in the Y. And this time, although we have been using, assuming upward positive, this time I will assume downward positive because like I always say, there is no other force present but the forces going down. So, it is impractical pa nga i-assume pa nako ang upward positive when wala na may laing upward na force nakita nato dire. So, it means F sub R is equal to F sub 1 plus F sub 2 plus F sub 3, which is F sub 1, 300, 1/8 of 600. 300, 1/8 plus 600. F sub R is equal to 2,700. 2,700 Newton. And of course, going down. So for our resultant location of our resultant force, so let us say that my resultant force is located here. Let me redraw this one here. This is my A and B, and let us say this is my resultant force, F sub R, which acts at a specified distance x. So therefore, we will do moment, resultant moment acting about point A is equal to the sum of all moments that acts about point A. Assuming, of course, this time I will also use clockwise positive because if you can observe from point A to F sub R uh, acts clockwise about creates a moment clockwise moment about point A, and also the three forces F sub 1, F sub 2, and F sub 3 also create a clockwise moment about point A. So i-assume na lang na to nga clockwise moment is positive for this example. So it means nga this is F sub R times X is equal to F sub 1. I will just substitute, okay. I will just substitute the values directly. Okay, let me delete this first. Okay, for my F sub R, that's 2,700 times X. Okay, now our F sub 1, that is 300. Again, clockwise. Times its perpendicular distance. We have measured the 4/3 from A, so we will use 4/3 meter plus, again, clockwise, force number 2, that is 1,800 or 1,800, 1,800 times its perpendicular distance. Now, the centroid on where our F sub 2 acts within the entire length of 6 meters is at 3 meters. So from A, that is 2 plus 3 meters. So meaning this is times 5. then plus again because it creates a clockwise moment. Now f sub 3 is 600 times the perpendicular distance. Now we have solved our 4/3. That is 1/3, meaning from the base of our triangle, right? So 1/3, so that is 4/3. So it means that the perpendicular distance of our f sub 3 is 2 plus 6 plus 4/3. So that is 2 plus 6 plus, and not times, 2 plus 6 plus 4/3. Anyway, I was just right. 8 plus 4/3. So 2000 divide by, let's see, 2700 times x is equal to 300 times 4 divide 3, that's 400, plus 1800 times 5, this is 9000, plus 4 divided by 3 plus 8 times 600, that is 5600. Then you take the sum and divide both sides by 2700. This should give us x is equal to 460. Oh no, not 460, but 400. No, this is 400. That is 0. 400 plus 9000 plus 5600. That's 15,000 divided by 2700. So our x is equal to 5.5556 meters from the left side. It says here that from the left support of the beam, or from a left support. Okay.